Now for a given acute angle, do we know how to evaluate each one of the 6 trigonometric functions at the acute angle? Let's look at a specific case. But before we evaluate any trigonometric function at a particular angle, I need you to quickly review what is the sine value for an acute angle. So we just look at the angle in a right triangle, right? So we use the side opposite the angle over hypotenuse. That's the sine value. So what is the cosine value at the acute angle? You look at a right triangle and use the side adjacent to the angle over hypotenuse. And what is the tangent value? Tangent value is the side opposite the angle over the side adjacent to the angle, etc. So cosecant, secant, and cotangent will be done similarly. So let's look at a specific case. So here's a triangle, an acute angle A. So if we look at this A, this is an acute angle, but actually there are 2 acute angles in this right triangle, right? B is also acute, but let's focus on A. First, we want to look at this acute angle, and we want to find all 6 trigonometric function values at A. Now let's just, that means we're going to find sine value at A, cosine value of A, tangent at A, etc. So let's get the value one by one. So sine value, by definition, the side opposite A over hypotenuse. So we use 5 over hypotenuse, which is 13. Cosine A. Cosine A is the side adjacent to A over hypotenuse. So we get 12 over 13. Tangent A. Tangent is the opposite side over adjacent side. So 5 over 12. Opposite means what? Means the side opposite to angle A over the side adjacent to angle A. So 5 over 12, that's the tangent value. So let's continue. We have 3 more function values to determine. So next one, we can do the cosecant. Cosecant A is hypotenuse over the side opposite A. So hypotenuse is 13 over 5. 5 is the side opposite the angle A. Next one, secant. Hypotenuse over the side adjacent to A, which is 12. And cotangent A is x over y, or the side adjacent over the side opposite the angle A, which is 5. So yeah, we have found for this acute angle A, right, all 6 trigonometric function values. And now let's look at angle B. So for B, let's forget about the previous work, and then we focus on another acute angle, which is denoted by B. So let's look at sine B first. Okay, sine B. Sine B. B is acute. We use that definition for acute angle, right? Sine at this acute angle is the opposite. So first of all, we need to identify which one is the side opposite the angle B. So here's B. 12 is the side opposite angle B. So for side B, it will be 12 over hypotenuse, 13. Now, next one is the cosine at B. So cosine at B, cosine at B, this time we need to use the side adjacent to B, okay, which is 5. 5 is the side adjacent B, right? Here's the B. So the side length adjacent to B is 5 over hypotenuse. That's the cosine B. And tangent B. Tangent B is for the B. Now we keep in mind we're working on the angle B. What's the tangent value? Tangent value is the side opposite the angle B, which is 12, over the side adjacent to B, which is 5. And then continue. For the acute angle B, we calculate cosecant at B, right, which is hypotenuse over the side opposite B, which is 12. Secant B. Secant B is hypotenuse, which is 13, over the side adjacent to B, which is 5. And last one, cotangent. Cotangent B is the side adjacent to B over the side opposite the angle B, which is 12. So we have found all 6 trigonometric function values for the angle B. So afterwards, we want to take a moment. We look at the A and B. They are acute angles in a right triangle. And we know these 2 angles, they are complementary to each other. That means the sum of these 2 acute angles is 90 degrees. So yes, so we have A and B, they're complementary angles, simply because the sum of 3 interior angles of a triangle is 180 degrees. Remember, A plus B plus C, the 3 angles will add up to 180 degrees. That is true for any triangle. So this is true also for any right triangle. So if that is true, then we know the C is a 90-degree angle. So if C is 90, then A plus B must be also 90, must be 90 degrees. So that means AB, the two acute angles in a right triangle, are complementary. The sum of the two acute angles is 90. And because of that, let's look at some special results. Look, the sine A is the same as what? Cosine B. It's not by chance because AB are in this right triangle. You see the side opposite to A is the side adjacent to B. So now we can look at another value, another pair. So another pair, let's look at cosine. Cosine A is equal to sine B. Because the cosine A, you see this 12, right? The side adjacent to A is the side opposite the angle B. Yeah, so it's not by chance. So it's actually it should be true, right? So cosine A is equal to sine B. So tangent A, okay, so let's look at tangent A. So tangent A is cotangent B. Yeah, because tangent A is the opposite side of A over the side adjacent to A. And cotangent B is the side which is adjacent to B. The side adjacent to B over the side opposite the angle B. Yeah, well, of course, the side adjacent to B is equal to the side opposite to A. Yeah, so that is some observation. So we want to point out that the A and B, when they are complementary and the sine of A is the cofunction of B. And that means cosine of A is the sine of B, right? They're just complementary to each other. So whenever they're complementary, then the sine value of the one angle is cosine value of the other. And same thing is true for tangent. So tangent of A is the cotangent of B. Or in other words, cotangent A is tangent B. And secant, cosecant. It's also true. Secant A is cosecant B. Or cosecant A is secant B. Yeah, so these identities are true for complementary angles. And we noticed these properties, and I will summarize them in the following page. Okay, so let's take a quick look. So that means we can establish the property that is cofunction values of complementary angles. So we can show these two angles, two acute angles that are complementary in one right triangle. See, here's A, here's B. They are complementary, and that means the sum of the two angles is 90 degrees. And just a quick view, because this is just a general case, right? A general case, that means it's a right triangle, and AB are just two acute angles in a right triangle. So ABC, capital letters, in capital letters, they denote vertices of the right triangle. And lowercase letters, ABC, see, this A is the side opposite the angle A. The lowercase b is the side opposite the angle B. The lowercase c is the hypotenuse opposite the 90-degree angle. So that's just a notation. So for the each capital letter and each lowercase letter. And now let's just take a look at the sign A, right? Sign A is what? Opposite side over hypotenuse. That's the sign A. But this A, lowercase a, is actually the side adjacent to B, right? So that's the adjacent to B over hypotenuse, which is cosine B. Yeah, when A, B are complementary, sine of A is the cosine of B. So it's not difficult to show that tangent A is opposite side over adjacent side, right? Tangent A, that means the side opposite the angle A over the side adjacent to angle A over B. However, that is cotangent B. Yeah, simply because this A is relative to the angle B that is adjacent side. This B, lowercase b, is the opposite side for the angle B. So adjacent to opposite, that is cotangent B. Okay, so then we can do one more, that is secant. So secant A. Secant A is the hypotenuse C over adjacent side of A, right? Adjacent side of A is B. So that for the angle B, look, for angle B, if C is the hypotenuse, for angle B, this B, lowercase b, is opposite side. So this for angle B will be hypotenuse over opposite side, which is cosecant B. Right, so you see for these two acute angles, sine of A is the cofunction at B. See, tangent of A is the cofunction at B. Secant of A is the corresponding cofunction at B. So, but A and B, we don't have to write this way. We can also write B as 90 degree minus A, correct? Because A and B are complementary. So we, instead of writing B, then we can use 90 minus A to represent the angle B. So to summarize the property, so cofunction identities, that is sine A equals cosine of the complement of A, right? That was the B. I previously wrote a B, so which is the complement of A. Yeah. Tangent A is cotangent of the complement of A. Secant A is the corresponding cofunction, cosecant of B. So that was B, what I wrote earlier before, but that is now denoted by the just 90 minus A. Yeah, so that is the cofunction identity for each case. So we have 6 of them. 6 of them. You see, sine, the cofunction is cosine, right? Tangent, cofunction is cotangent. Secant, cofunction is cosecant. Cosine, cofunction is sine. Cotangent, cofunction is tangent. Cosecant, cofunction is secant. So, but each of the 6 functions, sine, or each function at A is the corresponding cofunction of its complement.